Well, yeah, we finished the first topic. Now the second topic, estimate the cost. We estimate the cost. The cost, computing cost. Computing cost in computing time, the time spent solving this problem, estimate the cost. Yeah. All right. Yeah, the same problem again, but we need to evaluate. We just count the number of additions. This time we need to count number of multiplications. Okay, yeah, all right. Count the number for each term. Yeah. Actually, we did it before, right? Yeah, so we did it. Yeah. This time we need to add up the total number of multiplications. Yeah. Accumulate all the number of multiplications. Yeah. All right. Try simple. Yeah. Yeah. Simple example. Actually, we already passed this step, right? Yeah. Try simple. Yeah, but we passed this step. The answer is K. Yeah. Yeah. We go to the next step. Yeah. The next step. Here we do the chart. The first term, 1 multiplication. Second term, 2, 3, and so on. The last one, n. Yeah. Here we need a total here. Right? Is it easy to find a total? Sum of all the numbers. Do you know the formula? Everyone should know the formula. Simple. Yeah. 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 Right. This formula. Okay. Yeah. Yeah. So we get the total. This is the total number of multiplications. Okay. All right. Yeah. But we need to convert it to the units of time, right? Yeah. Yeah. In order to putting together addition time, multiplication time together, so we need to use the same unit. Yeah. So converting to the units in our assumption, extra assumption we made, so we multiply this number by 10. Each multiplication uses 10 units of time, 10. So you get a 1/2 times 10, you get a 10, 5. Yeah, 5n times n plus 1. So this expression gives us the total units of time we need to compute, to find the value of the polynomial. Yeah. We have concrete number. This number. Yeah. So the next question, how to reduce this number? Yeah. Because this number, it looks pretty big, 5n squared plus 6n. Looks pretty big. So the next question, is it possible to reduce that number a little bit? We want to find the same answer, but we don't need that many units of time. We want to save some units here. Using some smart way. You have to use some smart way. Otherwise, how can you save? How can you save units significantly? Yeah. It has to be very smart methods.
Like if you know x squared, to calculate x cubed, you just need to take the old x squared value and multiply.
Good. His idea is so good. Yeah. Get it? Yeah. I'm very happy to hear that. His suggestion, very good. What he says. All right. Look at here. 3 multiplications when we calculate this one. What he said, when we calculate x cubed, we just use the value of x squared because we already have it. We just need one more multiplication, we can get x cubed. Why? We don't need to do 3 multiplications, right? We just do one more multiplication from x squared to x cubed, then another multiplication here, so we can reduce by 1. But this idea, if you apply it on all the other terms, you can save a lot, right? That's a great idea. That's a great idea. That's what I call creative. Now, if you can do it that way, yeah, so you deserve that credibility. Creative. Yeah. Yeah. So in this class, we encourage that kind of behavior. Creative. Yeah. All right. Improvement strategy. Okay. Yeah. Do some observation. Yeah. We need to explore some special property so we can take advantage to reduce the number of operations. Here, first, based on our assumption, the cost ratio for the multiplication over addition 10-to-1 ratio. Yeah. What does this number tell us? 10-to-1 ratio. That's pretty big number. As a ratio, it's a pretty big number, 10-to-1 ratio. From this big ratio number, what conclusion can we get? Reasonable conclusion. Yeah. Yeah. So let me point it out, the conclusion we get. Yeah. When you do the reduction on number of multiplications and a number of additions, where is your focus? When you do reduction, you should put more focus on multiplication reduction, right? Because the gain is big, right? Look at that. If you can reduce multiplication by 1, then the benefit you have, that's the same as you reduce 10 additions, right? Yeah. From the time you save 10, 1 multiplication equals 10 addition reduction. So that means when you have limited investment to put in this algorithm improvement, you should put as a multiplication reduction, right? Because the gain is bigger. The gain is bigger. More cost-wise, better decision here. Yeah. All right. Focus more on multiplications because the gain is much bigger, 10 times bigger. Yeah. All right. Yeah. Strategy. Our strategy: reduce the number of multiplications. That's our main focus. Okay. All right. The question, next question, execution. Yeah. We have the strategy, but how do you reduce it? How do you do the reduction? How do you do the reduction, right? Yeah. The execution part, not easy. Yeah. Okay? Strategy time. When something not easy, you need some strategy, right? Yeah. Think about it. So what strategy you like to use here? Strategy. Okay? We just learn. Use that strategy repeatedly. Try the simple case, right? Can you try simplest but non-trivial? If you try trivial, nothing you can get. Because it's trivial, you can get nothing, right? But simplest, but non-trivial. Non-trivial, okay? Implement that strategy. Yeah. Reduce number of multiplications. Yeah. Yeah. This number we want to, yeah, this is addition number. Yeah. It looks like it's hard to cut, hard to reduce. This number so big, we have a lot of room to do the reduction. Yeah. So we should put our investment here. Okay? Yeah. Investment here. Yeah. All right. Next, for the execution step. Yeah. All right. So we need to look at the details for this question. All right. All right. So now the strategy, simpler case. Because here, before we have any experience, when we do some experiment, we want to start from a simpler case. Yeah. So that strategy, you can see, that's the most frequently used strategy, right? Yeah. You know, most frequently strategy we use. Yeah. All right, let's do the work. When n equals 2, that's a simple but a non-trivial case, right? Yeah, simple, non-trivial. So we can get some useful information here. All right. So we get a quadratic polynomial, right? Quadratic polynomial. Yeah. So we want to try very hard to reduce the multiplications. All right, let's look at the property. When you look at these two terms, any special property you can observe, the property, the last two terms, any special property you can observe, okay? Something, yeah. Your observation is very important. Yeah. You can see in problem solving, our observation extremely important. Find something, property. Yeah. Here, probably common factor. Can you see common factor x? There is a common factor between these two terms. That's the property. When you have a common factor, what usually do? What usually you do? Common factor. Factor it out, right? Yeah. Factor that common factor out. Yeah. So here, we change the form. Yeah. Change the form. The same formula, but in a different form. Yeah, so we transform the problem. We change the structure for a new outcome. Yeah. We do not want to change its value, but we can change its structure. Same value in different structure. How about that? Okay? Yeah. So here, let's do factorization. When we do factorization, we change its structure. Yeah. Factor this common factor out. So this one has different structure, right? Yeah. Yeah. So these two, same value, but different structures. Okay. Yeah. Then, when we work on two different structures, let's look at the outcome. If we have different outcome, okay, yeah. Count number of multiplications for the first structure. 3, because the first term we need 1 multiplication. The second term we need 2 multiplications. 1 plus 2, 3. Right? Yeah. That's the first structure. 3 multiplications. Let's count the number of multiplication for the second structure. Okay. All right. Addition we do not count. Okay. Addition we do not count. We only count multiplications. Yeah. So no multiplication inside the parenthesis, the first term. There is 1 multiplication inside parenthesis. 1, only 1. Another one, parenthesis, x times parenthesis, the second one. So you can see adding these two numbers together, we have 2 multiplications. Can you see improvement? From 3 to 2. Reduction. 1 multiplication is reduced. 1 multiplication is reduced. How about that? 2 different structures, but the outcome will be different. See? See? Conclusion. The conclusion. Yeah. If you can explore factorization property, if you can do factorization, you can save number of multiplications. The reason we can save, because we take advantage of factorization property. Factorization. How about that? Okay? So the factorization technique, yeah, we call it, it's a technique, factorization. Okay? Factorization technique can help us get the gain in time units, time, gain, multiplication reduction from 3 to 2. That's the conclusion. Yeah. For a simple example, you can already see significant gain. So this is significant, right? Yeah. 3 to 2. Although a small number, but significant. Okay? All right. The question, can we generalize this idea to the general N? General N. Okay? Yeah. Here, after we work a simple case, or simpler case, some simpler case. Now, we have the experience here. We have the conclusion here. Next, we want to extend it. Generalize this idea to general N. General N. Then, it's reasonable we can expect better solution, right? So here, with the knowledge or experience collected here, we expect some nice improvement when we work on the general case. Okay? Yeah. All right. Yeah. All right. Yeah. So because it near the, 3:30. Yeah. So, because we still, when we work on this general case, a lot of discussion. Yeah. Still a lot of discussion. Yeah. So I will leave to the next time, our Wednesday lecture. Wednesday at the beginning. So we complete this first. Then we start new topic after that. Yeah. But one thing, just 2 minutes before we end, one thing is this example, our first project about this example, our first programming project. We will see a good algorithm, a bad algorithm, how much is the difference? Yeah. So I want to show the power of a good algorithm. When you do algorithm in an extremely smart way, how much gain you can get? How significant? Yeah. I let you feel about it. So that's our first project. You can feel about it, okay? Using the first algorithm, the straightforward one, the plug-in one, okay? You sit there waiting 1 minute. 1 minute. Is that long? 1 minute. 1 minute response time. Feel about it. Is that long? You type enter, waiting for the output. You need 1 minute to get it. It looks like a century. 1 minute looks like a century, but that's the response time. But the second one, okay, see immediately. Fractional of time. Then you will see the huge difference. Okay, that's our first project. You see it, you will see it. So you will see the power. That's the power of algorithm. Okay, the power. All right, so that's it. Yeah. So that's our first lecture. All right, so oh, sorry, I muted. Wow. That still didn't tell me I'm mute. Sorry, but I will post the video. Yeah, I will post the video. Yeah.